Great with IT. Hi, I'm Ian Van Eden. I'm a principal here at Northrop, which means that we are shareholders in the business. So welcome to our home. It's only our home for another couple of months. We're moving out in November. Hence our cobbled together IT solution. Our IT department didn't want to fix that big one up there that I'm pointing at nothing at the moment, which explains why it's not working. So welcome to Northrop. I'm gonna not be hosting the whole thing. I'm going to hand over to Steve Hennessy from WT in a moment to do a bit of an intro, but I wanted to welcome you to Northrop, and I wanted to acknowledge the Gadigal of the Eora Nation and pay our respects to their elders past and present. But welcome to our office. I'm going to hand over to Steve now.
Thank you, Ian. Thank you very much, everyone, for attending. Thank you for those of you online. Before we start, and I know we want to get into it, Sharon has told me in no uncertain terms that I am to go through a few CIBSE announcements and get those out of the way. So the first thing I wanted to mention was CIBSE ANZ training. So CIBSE have spent the whole of COVID developing a whole load of training courses. Now, some of the guys I work with have been on these, and they say they're absolutely brilliant. And I'm not just saying that because I'm me, probably. Sorry for you online. But look, the good news is that the Young Engineers Awards are open, and they're open to everyone in the country. We've added 2 new categories to the awards this year, which actually recognise the people that are helping young engineers and their organisations as well. You've got till July the 29th to get it in. For those of you not in Sydney, the finalists will actually get flown to Sydney for the event. I do feel sorry for the finalists in Sydney because you're not going anywhere. Might get an Opal pass or something. And the winners in each category are up, I think, to get $1,000 cash prize. So not to be sneezed at. Some of you will also know that CIBSE's traditionally run conferences, and about 4 years ago we moved to an online format with conferences, and our next one is coming up on the 30th of July. Starts on the 30th of July. This is a really good format. They come on at midday. We do 2-hour sessions. We've got 5 of them, so 1 a week over 5 weeks. And the people that have been involved in developing these are the top of the game, and the people who are speaking are at the top of the game. This is a really good seminar series, so strongly recommend. If you haven't already signed up, sign up for it. You can watch them live online, and you get access to the presentations afterwards as well. Really well worth doing. Now, just going to touch on this quickly. But as many of you will know, a lot of the states are now regulating engineers. So if you want to sign off on drawings or what have you, you're going to have to be a registered engineer. It's already happened in Queensland. It's already happened in Victoria. The good news is that CIBSE has been working with the different state governments to make sure that CIBSE themselves can be an accrediting authority for people seeking professional registration. So those of you online and in Victoria and Queensland, if you're going for RPEQ or the equivalent in Victoria, you can transition through CIBSE. New South Wales is moving the same way. It's happening at the moment. There are talks in the background. CIBSE are in discussion with Fair Trade to become an accrediting group within New South Wales. So watch this space, but those of you that are CIBSE members, you'll be able to leverage off of that. And for those of you that aren't CIBSE members and probably frowned upon professional institutions like CIBSE. A lot of times, these professional institutions are accused of being perhaps a bit elitist. You've got to have your degree, and that's all very well, but there's a lot of people that have come into the industry haven't got degrees. CIBSE has a mechanism now that will allow you to become MCIBSE, so to get those letters after your name, without having to go off and do another degree or a degree in the first place. And it's called the experiential learning route to membership. Now, Sharon has given me a lot of information about this. I'm not going to go through it now, but those of you that are interested, scan the QR code or go onto the website or drop me a line or drop Sharon a line, and we can take it through that. The great thing about being a member of CIBSE is get access to the knowledge portal. The knowledge portal, basically, there's about $5,000 to $6,000 worth of guides and what have you. And when you're a CIBSE member, you just get access to this. You don't pay any more than your annual membership fee. Now, you can actually get access to at the affiliate level. So the affiliate level is about $300 per annum to be an affiliate member, and you get access to all these publications. And as these publications are updated, you get access to the latest publication. So take my area, which is commissioning. Just the commissioning codes alone will cost you more than the cost of being an affiliate member. So those of you who are here today that aren't members of CIBSE, give this consideration, and of course make sure that your company pays for it, and then you're even better off. And look, I'm really pleased to acknowledge our new sponsor for these events. The man behind this group has been a great CIBSE supporter for many years. In fact, he was one of our original sponsors. He's now got his own company, is Steve over there. So Sabre, as in Sabre, I've been told to say it that way in here. These events don't happen without sponsorship. They are quite important. So we're really pleased that Sabre are I think our national sponsors. Is that right? National sponsors. So not just here, but all the CIBSE events. So thanks to Steve. None of my guys are allowed to talk to him, by the way. But apart from that, now look, you didn't come here to listen to all of these announcements. You came here to listen to our two great speakers. Two speakers today: Brett Fairweather and Melinda Mandla. Have I got that right? Fantastic. Smooth. That was seamless. That was well rehearsed. Brett and I worked together many years ago. They were good days.
You told me to get
I suggested to Brett that he get involved with standards, and you're all going to suffer through that in a minute. Someone wants to be admitted, and it's come up to me. Brett's developed knowledge and practical experience in the application of local ventilation standards through his own work, but also through his contributions in the committee that was set up to revise 1668 Part 2 and 4, and he's also the chairman of 1668 Part 1. So we're absolutely delighted to have Brett come along, because you really aren't going to find anyone else who knows these standards better than Brett. In addition, Melinda is the Sustainability and Wellness Director for JLL Asia Pacific. And it says here she is specialising in, and then it's got Teams meeting against it. So that makes it very, very difficult for me to go any further than saying she specialises in. But actually, she specialises in design and operation principles, applying wellness certification standards to buildings. And she also has a lot of knowledge around Green Star performance, and introducing these kind of rating things at scale. So Melinda will talk after Brett. I'm going to let Brett take over, and he's going to pass straight on to Melinda after that. And I'm going to sit down and shut up. Thank you very much.
Thank you very much, Steve. And we'll have time for questions at the end, but we'll hold them all for the end if that's okay. Just we've got quite a lot to get through, so I'm hoping this is now working. Good. Okay, so topic one, I'm going to be talking about the new AS1668 Part 2, Mechanical Ventilation in Buildings. It's only just published less than a month ago, so it's very, very new. I'm only a few weeks ahead of you in reading the content that's in there. So this is an introduction to what you'll all be looking into over the next however long, and we're all going to be learning about the new ways of dealing with mechanical ventilation in buildings. So don't be too scared or too concerned. It's all new for all of us. So look, Steve's touched a little bit on who I am, so I don't need to go through that again. So topic outline. Going to be talking to you about the just a bit of an introduction to AS1668 Part 2, what it is, where it's come from. Talk about the regulatory adoption of the standard, how we use it, why we use it. I'll then provide a brief outline of the technical changes that have occurred in 2024, so you've got a bit of a sense for what's coming, and then we'll dive into some selected details. Not all of them, we'd be here forever. I'd find that entertaining. You all want to go home at some point. So we'll just look at some selected details, and over time, I'm sure as an industry, we'll start looking into more of the details in other ways as we're learning to use them. So introducing the standard, I'm going to go a bit through the history, its purpose, its objectives. I want to talk about dilution and filtration, so everyone's got a very clear understanding of what it is that the standard is trying to work with, and just understand some of the principles behind it, so it makes it easy to understand what we're applying. I'll then give you a bit of an outline of the revision process that we went through to get to the 2024 version of the standard. So the history, standard first emerged in the mid-1960s, then it was revised in 1980, 91, 2002, 2012 and 2024. There's an interesting one in the middle there that was published but never referenced in the building code. So it's an interesting way that these standards are used and adopted in different ways in different jurisdictions. The standard sets out the minimum design requirements, and Melinda's going to be talking later on about what we do after the design, after the building's been handed over, which is really important. We need to think beyond what we're designing on the page in front of us or the screen in front of us. We're designing these spaces for people to use and to occupy. As much fun as it is to design, it's actually there for a purpose. So remember that this standard is about the minimum design requirements. It is built on the principles of dilution and filtration, which I'll go into in a moment, with consideration to health and ventilation amenity. The standard relies significantly on the use of outdoor air, which is generally considered to be acceptably clean or acceptably fresh in a way, to want for a better word, but to displace indoor contaminants and try and sort of bring the outdoor conditions in, the outdoor environment in. Ventilation rates will exceed the minimum rates that we need for just general respiration. We need very little for respiration in comparison to the rates that are in the standard, because we need extra dilution, extra air movement to improve the amenity needs of most occupants most of the time. So that's what the numbers are based on. And those requirements are going to continue to evolve over time in response to industry knowledge and feedback and suggestions to the Standards Committee on what can change over time. So this isn't the end of 1668 Part 2, we're just partway through the journey of it. So the basic principles of filtration I mentioned, dilution and filtration. Dilution is where we're going to flush out contaminated air and replace it with something cleaner. Filtration is capturing some targeted contaminants, not just some random contaminants. They've got to be the ones that we're interested in the space. And then that's going to reduce our reliance on the dilution. So these are the basic principles behind what's in 1668. So diagrammatically, excuse my animation skills here, but this just sort of goes through what I've just mentioned. We have a space, we bring in a lot of outdoor air, and it's going to flush out the contaminants. So if we flush out those contaminants roughly at the rate that we're generating them from within the space, then we're going to maintain a bit of an equilibrium there at a rate that, at an amount that most people are going to be happy with that space most of the time. We can do that in exhaust as well, so we can take some air out, as long as you remember to design the makeup air, which is half the solution with an exhaust system. Then we're bringing in a suitable level of quality of air, which is then going to allow those contaminants to be drawn from the room. but we're going to have a bit of a different pressure balance between the spaces between the supply and the exhaust. Then the filtration is all about taking some air from the space, removing some of those contaminants that are generated in the space in some way, some filtration mechanism, and then we can put that air back into the space. We might recirculate it into the air handling system. But by doing that, we don't need to bring in as much diluting air to get the same overall effect. So that's the purpose of the filtration, particularly when you start looking at the Appendix D calculations that you might know a little bit about. Okay, so how did we get to the 2024 edition of the standard? This is just a bit of an outline of the revision process. So there was a project proposal. I worked with Standards Australia, I think back in 2019 to get that underway. So it takes a bit of time, and that's where the overall suggestions for changes went. So we're past that time now. We'll have a Q&A session later, but the overall suggestions for changes, they'll need a new proposal to get underway. The scope was then established and agreed, so the project was limited to what was included in the approved project. The project actually originally commenced very early in the very early days of COVID, and then we paused and waited to find out what does the industry need us to be dealing with here, and eventually we resumed the project in July last year. Then the drafting went through, editing went through, went out for public comment. Many of you could have seen the public comment that was out, and we got over 700 comments in response, and the committee had to go through every one of them and reply to every one of them. So for those of you who got a response, I apologise if the response was brief, but we had to try and find the best use of the committee of volunteers and our time to be able to respond to each of them. And there were some great suggestions in there that were out of scope. And I assure you they've been parked appropriately on a list of things to look at in the future as well. Public comment resolution then allowed us to take feedback from the industry, and where that feedback was within the approved scope of the standard, we could then revise and refine the draft into what's there now. Then the standard was published on 28th of June, so within the last month, and that's what's out now that we're talking about. Any further changes that need to be done in the standard will be subject to a new proposal. So, and anybody's able to prepare a proposal. Now, how do we use the standard? Well, make things complicated. Every state and territory legislates construction differently, and it can be rather complicated trying to navigate this from one state to another. But using New South Wales as an example, because that's where I'm standing, we've got the EP&A Act and the regulation, which require all building work to be completed in accordance with the Building Code of Australia, part of the National Construction Code. So all other states have a different way of getting to the requirement to build in accordance with the Building Code, but that sort of levels the field there. The Building Code then has volumes 1 and 2 of the National Construction Code and provides multiple pathways for compliance. So NCC 2025 was published for public comment draft in the last month or so, and it identified the intention to adopt 1668 Part 2 2024 for deemed to satisfy designs from the 2025 edition of the Building Code. We don't actually know when that'll come out. It's normally 1st of May of the year of its publication. So compliance with the NCCs described in NCC A2G1, you can go and have a read of that in your own time. And the use of 1668 Part 2 is not mandatory. It's one of the permitted pathways through there, or it's part of one of the permitted pathways through there, but the alternatives may be a bit more complicated if you understand the performance solution process. So with the compliance side of things, so there's a figure here out of our building code, which identifies that the performance requirements there, and I've just highlighted around that, the performance requirements are mandatory. There's no getting out of those. But then we step down a level and we can go to either the performance solutions or deemed to satisfy. And these are considered to be equally compliant once you get to the other end of them. But within the deemed to satisfy solution is where the reference to AS 1668 Part 2 exists. And that's what we're going to be focusing on now. So 1668 Part 2 is referenced for deemed to satisfy or DTS applications in a whole range of applications within the building code. And note also that draft changes to the NCC 2025 were recently published for public comment that I mentioned, which identifies that these are generally going to remain the same is what we saw from that draft. Then when we start getting into the standard, there's a really important clause that's often been overlooked. Section 1 of the standard tells us how to use the standard. It's often overlooked. There's some really important definitions in there and just processes that it's worth reading every now and then just to make sure you're understanding how we're using the standard. The 2024 edition now has clause 1.2, which is now called application, and it directs us to the relevant part of the standard to answer those questions like, should I be supplying or exhausting this storeroom? Very common question. This is the clause that will lead you to the answer for that. And I really want to stress that when you're dealing with these standards, when you're working with these standards, when you find figures, commentary, informative appendices, they are included to guide the users on what the authors of the standards intended and to improve the understanding of the readers. The written text of the clauses is the actual requirements. You shouldn't find the extra informative information conflicts in any way, but it's the written text that you need to comply with. That's important detail to understand there. Okay, so outlining some of the technical changes. The main changes are that non-quantified performance requirements and very loose terms that existed before, we had to work extensively to try and eliminate those. And so they've been replaced wherever we could with quantified prescriptive requirements. So I'm going to show you some examples of these. Calculation of minimum outdoor air rates has been presented now in simple and detailed formats. There'll be some familiar things in there, but it's just refined to make a quick path around some of the more complicated details if you don't need it. The concept of borrowed ventilation, I think this is a good one. I'm going to be talking about it a bit later on. Borrowing ventilation from a mechanically ventilated space. We haven't been able to do that under deemed to satisfy before. It's existed for a long time in natural ventilation applications through the building code, but we've adopted that and I'll talk about it shortly. Residential exhaust ventilation requirements have been aligned with what the building code already has for condensation management. So we still need to read the building code, but the requirements should be better aligned now. Contaminant generation rates for vehicles, for cars generally, have been updated based on the more widespread use of emission controls and an improvement in the vehicle fleet effectively. We know that the vehicle fleet has improved on average, but there are still some cars out there, some great cars out there that are able to drive around on the street and generate a bit more pollution than others. So the values, I'm aware, are still a little conservative, but we've been able to respond to the changing contaminant generation rates. We've got sections on kitchen exhaust and healthcare ventilation have been updated and expanded just to align with contemporary practice and technology, including a new deemed to satisfy compliance pathway for some limited horizontal kitchen exhaust, which will be a relief to many people. Commentary's been expanded just to get more improvement in that user understanding that I was talking about. So the commentary is not there to tell you what needs to be done. It's there to explain why we're doing it and how it's intended to be read and understood. Some notable changes. You'll notice when you start reading it that it's the styling of the document has evolved a little bit, just in line with how Standards Australia prepares their documents now. There's some editorial and technical errors that obviously we needed to tidy up on the way through. We've adopted some proven methodologies and technologies like reducing ventilation rates for car parks in response to the vehicle fleet and the horizontal discharge for filtration methods for some kitchen exhaust. Similar with the performance solutions, where there have been recognised performance solutions that have been repeatedly used with success. We can standardise those and make them a deemed to satisfy path without the complications that go with performance solutions. We removed outdated scope references, old codes and standards, revised things in line with updated filter standards and refrigerant standards, removed clauses and requirements that are out of scope and not part of mechanical ventilation. So there are a few fire-related items where the details are already addressed somewhere else, and they don't need to be duplicated or overlapped or confused in any way by a standard that's not supposed to be dealing with those things. So we've addressed that where we can. And obviously there's improved clarity of text, figures, and commentary along the way. There's less uncertainty. The old terms like reasonably uniform, reasonably accurate representation as far as practicable and nuisance that we all had to work out what to do with have been removed, and we've instead replaced them with quantifiable and measurable criteria. In some cases, it's going to require a little bit more design input, but it means that someone like a certifier can actually go and measure what you've done and be satisfied that it complies. So the process should be smoother. There are some scope clarifications, clarifying that the standard does not deal with infectious aerosols, but if we do need to consider that, then there's a reference to consider a recent publication from ASHRAE. Removed regulatory and audience references saying this standard is intended to be read by these people for this purpose. It doesn't need to be said. That's for other regulations to say how to pick up and use this standard. Revised and clarified the selection of mechanical ventilation, that clause 1.2 to direct us to which systems we need. And there's a new definition that's likely to be of interest to a lot of people. An occupied enclosure is now defined as an enclosure within a building that's intended to be occupied by an individual for 30 minutes or more per day. So it's quite limited, but we'll see how that comes. Those of you who've just picked up and understood that will see there's some importance in that to clear up how we're ventilating some spaces. Intake locations, again, measurable separation distances now for intake locations, less ambiguity. Outdoor air calculations are presented in simple and detailed procedures. Borrowed ventilation from secondary enclosures. These are all parts of the things that are in section 2, just the highlight reel of section 2. Filter efficiencies, we've got more choices, 3 different standards now we can refer to for the filters we're using, which is great. More options from international products, for example. We've got evolving guidance on population indication for demand control ventilation. And Appendix A has been updated. It's a much bigger list now. There's multiple extra pages in Appendix A to help you try and work out what type of space you're dealing with and what ventilation it needs to have. Okay, a highlight reel for section 3, exhaust systems. More detail on when hoods are required. So type A and type B has been resolved into almost a whole page, I think, of identification of what is a type A and type B exhaust, so we know then we need a hood. Kitchen hood and cooking process types have been clarified. Grease removal devices have been consolidated. I'll explain that in a bit more detail later. There's a horizontal kitchen exhaust treatment method for some limited applications, which caps out at about 5,000 litres for now, while we look at how the industry's responding to this and adopting it. Section 3 defers to 1668 Part 1 for requirements for protection of kitchen exhaust systems for the fire hazard properties, because all of those requirements are dealt with in 1668 Part 1. I can explain that a little bit more later on as well. Appendix B has also been updated just for some clarity. Then we get to the car park ventilation or vehicle enclosures. This standard has never been set up to deal with vehicles for the purpose of charging electric vehicles or for these automatic vehicle storage systems, or what people have come to call car stackers. These are just outside the scope of the standard, but there's some commentary in there just to remind us all that this is outside the scope. The word stack parking that existed in the standard from back in the 80s or the 90s was talking about that old end-to-end parking format where you'd have a couple of cars running while you're shuffling cars around and things. So we've replaced the term stack parking with tandem parking, because the term car stackers has sort of got legs and taken over. So we've adopted a term just to avoid confusion there. Car park ventilation rates are now down from what was a minimum of 2,000 litres down to 1,000 litres. So I will come back to that shortly, but that's a big change for a number of reasons. Use of different usage factors per zone for car parks. Some of you might understand what that means, but I'm going to explain it later again. There's some clarifications for car lift ventilation requirements as well. Then when we get into section 5 for healthcare, we consolidated some details rather than saying the same thing in several different ways in different parts. So where we refer to HEPA filters and door opening forces, it just refers back to some common clauses. It's just a neater way of doing it. General alignment with the Oz HFGs for some consistent terminology and some updates to air change rates and air distribution requirements in there as well. Introduced 3 new health facility enclosures to help us in adopting and applying the standard. And there are some clarifications for ventilation, filtration and exhaust provisions. So yeah, look, I'm recognising that the slides are very text heavy. I just try and just sit back and absorb this. I'm going to start getting into some of the details now. And these hopefully just prompts you the areas that you might have some interest in to have a look at after the session today. But we will have questions at the end. So now I'm going to review some of the selected details. So I'm going to start with outdoor air intakes. I've got the clause number in the top right corner there. So clause 2.3 is the one I'm going to just explore a little bit here. We previously had a requirement to assess the contamination sources near the outdoor air intake for a level of significance or requirements, wind effects and other factors, whatever that meant. We can't say those sort of things anymore because no one can really demonstrate that they've considered these other factors effectively. So now outdoor air intakes need to be located based on measurable separation distances between the intake and other devices or systems. And there's a table for that. The distances apply for concurrent operation. So an example there, one of them is the exhaust pipe from a diesel pump room. It's been managed very badly in my mind, it's been managed badly in the fire standards that call up for these systems in not prescribing sufficiently where to discharge these. Now you can't have an outdoor air intake right near one. We need to think about concurrent operation because these things can operate while the building's occupied for maintenance. So we can't just say it only ever runs in fire mode. That's not quite correct, but we acknowledge some of these sort of details in the standard. Some of the distances in the table are measured by string line. Others are measured horizontally only. It's fairly prescriptive there. Where plenums form part of an intake, this is an area that has clearly been looking for a word other than abused, because it's been used in ways where we're not really getting the right quality of air at the end of the plenum. So if we've got plenums that form part of an intake, they now have to have a sign on the door saying don't store anything in here. How the building owners will manage that is out of the control of the design standard. The design standard just requires us to design a label for the door. So separation distances were set out in accordance with the table 2.1. So it'll be separation distances from cooling towers, from gas flues, from sewer vents, and from fixed diesel engine exhaust. So a lot of these things aren't related to design decisions that are made in the standard. We're, as an industry, struggling to, coordinate and manage distances from these. So the standard now sets some figures in there that we need to work with. Oh, I haven't mentioned the AI imagery yet. For those of you who are sort of zoning out a bit with some of the text, you can have a look at the images I've generated on the left and try and work out what on earth it was that I was typing in to get that sort of image coming back from it. Anyway, I'll continue. Filtration, mandatory filtration, the bits in section 2. For coils and humidifiers now extend to protect heat exchangers as well. Minimum filter ratings have been expanded with some more choices. So in addition to the AS1324, we've now got reference to the ISO standard and the ASHRAE standard. And I want to note that these choices aren't necessarily equivalents, and the filter type for one of these may not be as practical as the filter type for another on the same level of the table. What it identifies is the choice you've got for the different applications between these different grades of filters. We've also got optional Appendix D strategies, retain the old AS1324 figures, but now also allow those options with the ISO and the MERVs. Outdoor air mixing and distribution, that old clause that said a reasonably uniform distribution of outdoor air shall be achieved. How do you work out what is reasonable and what's uniform and all of those things? Now we have measurable positions of ventilation devices, which is the greater of, not a choice, but greater of a set of 3 things. So the maximum distance from any part of the enclosure. So you can't have something 50 metres away and expect that it's going to ventilate this back corner. Twice the height of the enclosure, and also an assessment of the terminal velocity of the device you're using. Obviously, 50 metres, you can get some jet diffusers that will, get some effective air movement a long way from where they are. So we get the greater of these. So a bit of design opportunity in there as well. Outdoor airflow rates have been amended into the choice of 3 methods. Got the simple procedure and the detailed procedure. I wanted that to say the Apple procedure and the Android procedure, but I've got at least half the audience on side now and the other half offside, I'm sure. And we've also got borrowed ventilation in there from mechanically ventilated spaces. I think this is a huge opportunity for some of those spaces that just seem like this really doesn't benefit from having the ventilation, but at least now we've got some rules around when we don't have to ventilate some of these little spaces that no one really goes in much, and they're not densely occupied. So when we're applying this, ventilating the secondary enclosure with air that's borrowed from a primary enclosure, it's subject to all of a list of criteria, not just any one of them, but all of them. I'm not putting them all on the screen at the moment. You'll need to go and read through this yourself, but just as a bit of an outline, you can only borrow air from certain types of enclosures, not every enclosure. The outdoor air quantity in the primary enclosure needs to be enough for the size of both of them. Similar principle to borrowed ventilation for natural ventilation. The secondary enclosure is not an occupied enclosure. So remember that definition we had before, which was the amount of time and the density and per person per day, those sort of things that are in there. So that plays into it. There's an occupant density limit. There's a maximum distance of any part of the room from the opening. We've got to be cautious in introducing these new requirements, so they are quite conservative. And also the percentage of the opening between the primary and secondary enclosures needs to be a certain size, which is aligned with the NCC requirements for natural ventilation. What we're doing is setting some rules around how we can effectively borrow air from a mechanically ventilated space. And this might be useful for some spaces like storerooms is a really obvious one. Cool rooms, often forgotten. They were a room that needed to be ventilated, just it wasn't done because it's clearly not energy efficient. Utility rooms, equipment rooms, saunas, fire isolated exits that are used during normal building operation. And they seem like obvious things, but now we've got some rules around it. While this hasn't come in as a deemed to satisfy path under the building code, it is published and it is available for people to start adopting as performance solutions to help navigate through some of these issues. Demand control ventilation population indicators. So remember, demand control ventilation is all about making the air quality as poor as possible to save energy. It's not making things better other than we're saving energy. So it's a long-term gain. But we've reduced the focus on CO2. It's not the only indicator that we always need. It's been very commonplace because it's been a fairly reliable sort of proxy for what we're doing, but there's also some guidance in there talking about things like an occupancy schedule, nice and simple, nice and cheap. Gas contaminant sensors, digital occupancy tracking as technology is changing, visual occupancy tracking, not going into the details of them. So as the technology evolves, it'll fit into this. So the standard's not left too far behind. I've underlined in the top bit there, though, that the indicators need to be placed in each enclosure. That's what it says at the moment. If we're dealing with these, we need to be measuring each enclosure. I've heard some arguments in the industry about not necessarily being in each enclosure and just using the return air. It's a very old way of doing things and it hasn't been permitted for a long time. So I just sort of try and drive that home while I can. Clarity around storeroom ventilation. Everyone has questions about storeroom ventilation when we're ventilating. I'll just step through how we think we've tried to address this. So NCC clause F6D6, so I'm using the NCC 2022 number in here. In F6D6, which used to be F4.5, says we need to ventilate a space either mechanically or naturally. And it gives us a list of 9 examples of different types of rooms. And then it says, plus any other room occupied by a person for any purpose. They're the words in the standard. And there are no exemptions in that for the duration or frequency of the occupancy. Now, if you've got in your mind, yeah, but it's not habitable, I encourage you to go back and read the clause and understand how habitable is used there in a certain way, but that doesn't give you an exemption from everything else in the list, including any other room occupied by a person for any purpose. It's very, very broad, and it results. Well, I'm seeing a lot of spaces aren't being ventilated because people get caught up on that habitable term, which is an incorrect use of it. Anyway, under the 2012 version of the standard, we go into table B1 and we find a reference to a plant room / storage room for exhaust ventilation. So a lot of people will exhaust plant rooms and storage rooms. Table A1 has a range of different storage areas for different types of buildings. But there is a little asterisk there in the heading for occupancy that when we read the footer of the table says, if you find one of these storage, well, not storage types. If you find one of these room types in the wrong type of building, it applies to other buildings as well. So an example would be a storage area in a dry cleaners, for example. You'll find that in table A, but it applies to storage areas in other types of buildings as well. But we tried to clear that up. Now, table A, point 1, new styling. We've got storage rooms for supply. We've also got storage rooms for exhaust when it contains volatile. So it should be a clearer decision for these sort of things. I mean, storerooms are a minor part of it, but they seem to be a big issue, a big cause for confusion. So hopefully we've cleared that up a bit. Quantification of exhaust locations, the old clause 3.2.2, all of these wonderful terms. As far as practicable, exhaust air intakes shall be located on the opposite side of the enclosure from the source of makeup air. A number of times I've walked into an apartment bathroom and found the exhaust just inside the door or above the toilet or something, and not complying with this it's very, very widespread. But the standard has changed to take out the as far as practicable. That was, I think, often taken as, well, they wouldn't let me put the exhaust over there. Not what it says. Now we've got measurable limiting distances from the path of makeup air. It's not as complex as car park ventilation air paths, but we take a distance from the path from the makeup air to the exhaust, and no part of the room can be more than a certain distance from that. So it's measurable. Someone can verify that you've done what was required there. There is a note that does say multiple exhaust air intakes may be necessary, and so that's a design decision to make sure you don't have a spot in the room. It's not saying you must achieve this with a single exhaust. It recognises that there may be situations where you do need an extra exhaust to effectively ventilate the space. Maybe we did before. Type A and Type B effluents. For those of you who had been through the list of Type A and Type B and trying to work out what am I dealing with here, this should be a whole lot clearer. So we're into section 3 now. Clause 1.2c is what directs us to use a local exhaust system, which means we're using a hood effectively most of the time, and directs us to make considerations about Type A and Type B effluents. There's listed inclusions and exclusions. All of the Type B inputs are listed. We've added any cooking apparatus fueled with solid fuel is now Type B, regardless of the air quantities. And we've got some limited process types 3, 4, 5, and 6. Now limited to needing the Type B exhaust only if they're co-located within 2 metres. So if you've got some little facilities where you've got some little plug-in toasters over here and something over there, and it's fairly sparse, it's not requiring this level of exhaust. So there's some practical considerations there. We consolidated the reference to what was grease removal filters in Appendix E and grease removal devices just into one standard where we can deal with it all together. It just should make a little bit more sense, and we focus on the description as a primary device. So, you know, secondary attachments and features and things aren't caught up in the requirements for the testing and things there. Updated some kitchen exhaust hoods, revised hood type figures and calculation examples in Appendix E. Should be easier to follow now. Cooking type processes have been clarified with examples for each of them. So we've got lists of different types that will fit into them, and there's more examples in there too. Makes it, again, easier to work out which cooking type process we're working with. There's a new cooking process, type 8. Anything that emits smoke and embers. It's going to include flame grills, wood and or charcoal devices, but it excludes flavouring wood that's enclosed in an appropriate spark arresting device there. But they'll be called up as a Type 8 exhaust now. And then there's a table for process type hood overhangs, rather than trying to navigate through the tables and the figures and the words and the figures. And we're always chasing around numbers in the revisions for the standard when they weren't quite lining up. We've got a table now, so it should be simpler. And again, the fire safety requirements for kitchen exhaust hoods still exist. They're called up through the building code, but that's deferred to 1668 Part 1, which was updated after the last edition of 1668 Part 2. So it's brought in the requirements in readiness for shifting the content to the right requirement, the right area. Okay, replenishment of exhaust air. We've got some listed options for makeup air. Nothing new about the 12 pascals. Just remember that we do have that 12 pascal limit there. Limited options can be by supply air, appropriately located outdoor air intakes, appropriate adjoining rooms, and from an adjacent car park, but only in limited circumstances. So that's broadened a little bit, but we've got to limit it to appropriate locations. There's a bit of a relaxation of choice of the source for non-occupied enclosures. So again, we get to draw on that new definition of an occupied enclosure there for when, you know, it's a different type of space. And there's some more commentary on energy saving building facades, occupant use, and occupant expectations regarding the energy and efficiency and security of their home, where they may not want to have the windows open, and we need to consider what sort of provisions are in that design. And I always encourage everybody to make sure our designs clearly convey to the user, if we're working with a naturally ventilated space to save on the cost of ventilation, we've got to tell them that they have a responsibility to open their windows to be part of that ventilation solution in their space. If we don't tell them, they can't be reasonably expected to know about it. Air discharges. The 6 metre radius has been extended to all instances of multiple discharges. I think it used to just be limited to certain type B exhausts. There are now concessions. The old C3.10.3 was written as concessions for the horizontal discharge of kitchens. It was never written in there as a permission. It was guidance as commentary. Remember, the commentary is not mandatory. It's been deleted to avoid confusion, but we have put in a new permitted path for some horizontal discharge. It doesn't take away the opportunity to have a performance solution for these, which is the status quo on that anyway. Objectionable effluent discharges are now broken up into any type A is objectionable. Type B for any cooking appliance fueled by solid fuel, regardless of the air quantity. Anything over 1,000 litres a second when untreated, which is where we're at the moment anyway, and anything over 5,000 litres a second if it's been treated in accordance with the new treatment clause. Where we used to say all exhaust air shall be discharged to atmosphere in a manner that does not cause danger or nuisance, whatever that meant. We've now got minimum separation distances have been revised. Anything over 400 litres a second needs to be directed at 30 degrees, upwards at 30 degrees and away from outdoor occupied spaces. So you can't just blow the garbage exhaust out onto the barbecue area in a building anymore. 6 metres for all enclosure group 6 items. So anything that's a boundary trap, garbage room, grease trap, sewage ejector enclosures and things, you just got to have more distance for those. They cause nuisance. They're known to cause nuisances, so we've got 6 metre minimum for those. Minimum separation from floor level if you're dealing with 200 litres a second and up. Again, we're avoiding nuisance and disturbance and danger and all of those things. There's commentary to encourage louvers to turn the air away from people in the area of discharge. Horizontal kitchen exhaust, the deemed to satisfy path that will now be available. And remember, this is going to be an opportunity for performance solutions now, which might limit some documentation and things. The airflow is limited to a maximum of 5,000 litres a second for this application. We've got cooking process limitations. We've got primary filtration in the hood. We need filtration, a pre-filtration of an EPM 10. And we've also got an EPM 1 additional filter stage. It's pretty onerous. 0.2 second time, the contact time, I've forgotten the term, activated carbon for odour reduction, and a whole series of interlocks to prevent misuse. So if someone takes all the filter banks out because they're a nuisance to clean, the system won't work. Accessible location for all serviceable parts. Now, again, this doesn't change anything about doing horizontal kitchen exhaust with appropriate filtration under a performance solution. That's situation normal for what we've got at the moment. What this does is for a limited set of applications, we've got a deemed to satisfy path that doesn't require that performance solution process. It should be seen as an improvement in what we're doing. And I'd really like to think over time, as technology becomes more and more tested and proven, that we'll be able to add others into this. But for now, we've got this strategy. Continuous background ventilation will be of interest to some people. We've introduced a type of space, a high performance dwelling, into Appendix B. Now, this can be tricky, particularly in New South Wales, where we actually have to design something before we can build it. But the idea is, if you measure the completed building envelope and it achieves the set leakage rate, so it's fairly high performing, and mechanical outdoor air is introduced into that space, then the exhaust airflow rates may be reduced for the kitchen, the laundry and the bathroom, but they must operate continuously. So it's loosely aligned with the passive house sort of strategies of bringing down the air quantities, but running it all day rather than just having it when someone's in the space. So a bit of an opportunity to work with there. I'm sure that'll evolve a bit over time. But that may conflict with and so be overruled by the condensation management section of the building code, which doesn't currently permit anything below a certain amount in some of those spaces. So just be careful in how you're navigating through that and make sure you're not inadvertently not complying by just following 1668 without referring to the building code. Car park ventilation. It applies where combustion engines are parked, which is an activity involving people driving an operating car into spaces. Section 4 remains built on the principle of diluting contaminants from operating engines, not just cars being in the space. So the space is suitable for its intended limited occupancy. So people are coming and going from these spaces. They're not working in these spaces all day. The old 2,000 litres a second has been reduced to 1,000 litres a second, and related contaminant generation reductions have occurred in there as well. So big opportunity there for space saving, for energy saving, for the coordinated infrastructure saving of power supplies and the like. So I'm sure that will be warmly welcomed. And I am hearing of a number of performance solutions already being prepared to adopt this for the benefits that come with that. The P factors in the parking calculations now only apply in the absence of site-specific data. So if you've got something specific to a site for how it's going to be used to control the number of vehicle turnovers per car parking space, you can use those values. Where you've got different P factors for, say, residential and commercial or residential and retail, you can use the P value based on the zone where the vehicle's parked. I think a number of people were sort of using that in a way anyway, but now that the standards are clearly acknowledging that's viable. Some clarifications for vehicle lifts. We are dealing with them like a vertical parking aisle with an operating engine and a person in those. So they're dealt with in the same way as if the car was moving horizontally through the space, but they're now moving vertically between different areas. And table B1, interestingly, has an EV-only enclosure that's been added in there. We may start having those at some point, who knows, but they still need to be ventilated, but there are some provisions in there that aren't part of Section 4 because they don't have operating internal combustion engines. There are some changes to energy saving control provisions, which are aligned with the existing NCC. So it's mandatory to have something like carbon monoxide detection and operation, or the small car park systems, which are a series of timers and sensors and things. So they're now mandatory. They're not a choice that they were in 2012. And we've also added in a new mechanism of notification, which I hope doesn't look anything like that, but AI imagery, this is what we get. When the space exceeds EL30, and staff are using the space in non-fixed locations. Think of people collecting trolleys, equipment servicing, those sort of things. They need to be notified that the air quality in that space is not suitable for a workplace. So whatever that mechanism of notification is, that we'll just need to find out what that is. It might be a sign, a flashing light, someone sending them a text message. Like there's all sorts of ways that can be implemented. We just need to design that into the process. But if people are working in these spaces, they shouldn't be assuming that the car park's ventilated for anyone just to be in there as long as they like. That's not what it's designed for. CO sampling points, taken out the term as far as practicable and sorted some things out. We've reordered the list. It became quite apparent that a lot of people stopped reading at all parts of the car park, not more than 25 metres, and didn't read the rest of them. So we moved it down to item 3 to make sure you don't miss some things along the way. It'll have a significant change. We've got a reminder that additional detectors may be necessary. So it's not just about the 25 metre one, but maybe where people are congregating near lifts and things, we might just need to put an extra one, even though they're within 25 metres of each other. We've also added an item for where people work. So if you're going to have all the condensing units sitting in a car park, you've created a technician's workspace there. While they are working on that equipment, they deserve the sensing and control that goes with working in that space. Moving into section 5, we're nearly there. It's full on, isn't it? Applies to particular enclosures which differ from other mechanically ventilated enclosures via clause 1.2. So these are a bit different to something a bit more special than some of those. Revised for alignment with the Oz HFGs. There are 3 new enclosure types. Note that when we're dealing with the air change rates in these spaces, we're using the air change rates for particulate arrestants, not for infection control. Infection control is managed outside this standard. It's beyond its scope. Consolidation of previously repetitive requirements. I mentioned this earlier on. So the HEPA filters and the door opening and closing forces, they're all covered there in some consolidated requirements that are just referred to consistently. Amended terminology for alignment with the Oz HFGs, air change and distribution updates, again for more alignment. There's unidirectional operating theatre airflow. And there are some new air pressure diagrams in there to guide us through it. So the bit you've been waiting for, a quick recap on what I've just spoken about. I'll go back to the first slide and just skim through them. Introduced 1668 Part 2 to you, just a bit of an outline of where it came from, looked at how we use it, how it's adopted through the regulatory system, outlined some of the technical changes just to give you a bit of a sense of what was coming, and then went into some of the details. And I hope some of you along the way picked up on some things that are of interest to you and have some great questions later. But first, we need to talk about what's often forgotten by designers, which is what the ventilation system means to the occupants and what happens after the commissioning process. So I'm going to call up Melinda to have a chat now to us, and then we'll have a consolidated Q&A session.
What I don't have is super fun AI, but what I'm going to do is really going to be embarrassed if no one joins me. Does everyone want to just stand for like 20 seconds and like really? No, this has happened to me before. This is why I don't ask. Really just so everyone can recenter. If you have been sitting down, if you do need to like, you know, adjust yourself, please take this time to do so.
You're allowed to sit.
I'm allowed to sit.
I should have been standing for an hour.
How to tell I'm a wellness consultant 101. I will make you all stand and not sit down. Or give people the chance to leave. That was a terrible idea. Oh my Lord.
This is going to be very dangerous.
Thank you. I made a terrible choice. People went to go drink. I'll just give everyone 20 seconds to pick their beverage of choice. I'm so sorry. I'm rushing you now. So on a completely different angle from what Brett has introduced, I am the Sustainability and Wellness Director from JLL. I work with an incredibly passionate team of sustainability professionals who deliver different holistic sustainability and wellness certifications, WELL, Green Star, and the like. My personal wheelhouse is working on fit-out design and construction and operational Green Star and WELL certification. I have had an immense pleasure in my career working with some really, really incredible mechanical engineers who are definitely into interpreting these standards and helping us bring them to life in our projects. The entire design teams are collaborating with our client teams to be able to work together and create holistic outcomes within the client spaces. Sometimes we're addressing tenant feedback, sometimes we're addressing organizational goals, and generally hoping to create happy, healthy, and productive, efficient spaces. The one thing that remains the same for every single project I've worked on is that these spaces are being created for people. I'm so sorry for those of you working for data centers, but for the most part, buildings are being created for people. So we want to make sure that there is enough fresh air for people to breathe. The National Health Medical Research Council defines indoor air within a building occupied for at least 1 hour by people of varying states of health. So that can include offices, classrooms, transport facilities, shopping centres, hospitals, and homes. So indoor air quality can be defined as the totality of these attributes of indoor air affecting a person's health and well-being. As buildings are becoming better sealed from the external environment, indoor environments are having pollutants found at higher concentrations. So it's of vital importance that these spaces are being designed to ensure adequate ventilation, to ensure a comfortable indoor environment. let's talk about the importance of well-ventilated spaces. So low ventilation rates are associated with increased illness, absence, sick building syndrome symptoms, negative outdoor odor perceptions, and reduced task performance. The term sick building syndrome is used to describe an excess of chronic symptoms, some short-term symptoms including irritation of skin, eyes and throats, headaches, drowsiness, and general irritancy. Long-term symptoms can be cancer, respiratory disease, and periodic exposure to chemicals such as formaldehyde is also incredibly terrible. To paraphrase, when removing or reducing these pollutant sources is not possible, ventilation becomes the most important tool to ensure the effectiveness of occupants in the space, replacing polluted indoor air with clean outdoor air. So remembering that indoor pollutants can come from a myriad of sources, and it's borderline impossible to eliminate these pollutants. Perfume, cooking, cleaning, air fresheners, hobby supplies. As a cosplayer, I use a lot of contact adhesive, pesticides, dry clean clothes. The list goes on of where VOCs are being entered into your environment. So research focusing strictly on the health benefits finds that increased ventilation is associated with reduced rates of SBS and potential improvements in cognitive function and respiratory health effects. So for those of us who are working in spaces that children inhabit, the World Health Organization reports that 93% of the world's children under the age of 15 are breathing air that is so polluted that it's putting their health and development at risk. So, talking specifically about the exposure to pollutants, ventilation systems bring outdoor air inside, which all of you clearly know, and without proper treatment, these pollutants can enter that space, with approximately 65% of exposure to outdoor air occurring indoors. So managing both the indoor and outdoor pollutant is necessary to achieve holistic building air quality. So poor environmental conditions in the workplace are associated with around 10% of productivity loss for employees. Inhaling elevated levels of particulate matter has been shown to lead to various adverse health effects. So cardiopulmonary disease and high levels is the leading source of mortality amongst all outdoor air pollutants. Exposure to VOCs such as benzene, formaldehyde, toluene is associated with irritation of eyes, nose, throat, liver, and kidney damage. And the effect on the central nervous system may be an early indication of high VOC exposure. Carbon monoxide is associated with fatigue, headaches, nausea, and other health effects, including death. And ozone can trap air in parts of the lungs, adversely affecting lung functioning and triggering respiratory system symptoms like wheezing, coughing, chest pain, and shortness of breath, making the lungs more susceptible to damage and disease. So now that I've adequately scared everyone about why ventilation is really, really important, good design is not enough. What happens after designers step away? So while AS 1668 outlines minimum design requirements for minimum ventilation in buildings, it doesn't dictate how those buildings should be commissioned, tuned, maintained, and monitored. So Green Star Buildings encourages approaches through soft landing, meaning that facilities management teams and owners' representatives must be involved in the commissioning and handover process, taking part in development of technical guides, and building O&M manuals, signing off on these, and partaking in training before handover. These approaches should allow for inclusion in maintenance contracts of the requirements to maintain these systems to operate at those high performance levels that everyone has taken such care in designing, and the opportunity for the FM teams to work through questions prior to handover. Monitoring systems, so depending on the system's design, whether it's demand-controlled ventilation, on-site air monitoring, sporadic spot testing of indoor parameters, these tools are vital to ensure that building ventilations are being maintained throughout the time of occupation. And like all things that are no longer new and shiny, systems will need to be continually tuned to ensure that performance is remaining peak. And I've spoken really fast and got through my slides really quick. So certification frameworks. As building certifications professional, it would be remiss of me not to talk about the recognition of AS 1668 and third-party standards. So Green Star and WELL both reference the standard, but without my crystal ball, I can't necessarily know exactly how they're going to implement that in for the 2024 standard. WELL calls out an allowance for the 2012 version or a more recent version. And generally with Green Star, new standards are recognised through FAQs and the like. But please remember, if you are working with these standards, to check with the various rating systems as well. The intention of these rating tools are clear. They're encouraging ventilation supply rates prescribed to the standard to reduce pollutants within the space. Well as a minimum requirement requires AS1668 to be a minimum requirement for every building in Australia that's targeting WELL certification. And then you are increasingly recognised for improvements, so 30 and 60% for WELL, 50 and 100% for Green Star. Thank you.
Oh,
Yeah.
one more slide.
There we go.
There we go.
Q&A session.
A couple of mics as well.
Oh, good.
If you want to. If you want to sit us around, if you want
Well, first off, that was absolutely fantastic. I mean, I knew Brett, you knew a bit about the standard, but wow, that was great. So that no one will have any questions now because you've explained absolutely everything.
I'm mindful that for the online people, they may need to hear me there.
Can you we'll get a confirmation.
Anyone online confirm that you can hear me, please?
No.
We got that.
Thumbs up.
Yeah.
Okay. All right, that'll do. Thank you.
Because we have some online questions. I think you've already had a look at one.
No, I tried, but then.
Ian, do you want to ask the questions on behalf of the online audience?
As someone without a mic, I'll ask them and then I'll ask them. So we've got a couple of questions around whether or not the updates to the guide have considered things like the recent studies linking childhood asthma with gas stoves and things like that. Is there much guidance on that? Because I know
That's I'll say that's completely outside the scope of 1668 Part 2 for what's happening there, but that's not been addressed in this project. It wasn't part of the scope of the project.
I'll leave the other one to the aspect because it's very complicated.
You think it sounds complicated? Are there clarifications for outdoor air requirements?
Yes.
Hang on.
Oh.
Well, it is complicated, isn't it? I only saw the first paragraph. I didn't realise it went on for two more. But are there clarifications for outdoor air requirements for non-occupied enclosures, i.e., less than 30 minutes per day? Section 2.2.2 has occupancy as the greater of the maximum number of occupants present in the closure for any period exceeding this, or 1/3 of the maximum number of occupants present in the enclosure at any time. For space like airlocks, where it's safe to assume that only one person will be present under 30 minutes, is it fair enough to use 1/3 of the required outdoor air requirement? That might be a question on notice, Brett.
I'll have a go at it. I think with the introduction of the occupied enclosure definition, I don't think it's really been fully enabled yet. I think there's opportunities to use it in more of the clauses in the future as we come to terms with it. That clause 2.2.2, I think you mentioned, with the different occupancy calculations is a slightly different part of the application there. I think for an airlock, I'd be exploring whether you get borrowed ventilation from the adjoining space. Might be a way of working with that. We're trying to deal, we tried to, it's not ongoing work anymore, tried to deal with some of those sort of applications where it just seemed like a dedicated supply to those spaces didn't seem to be problematic. So we've tried to tackle that, and it'll really be up to everybody's application of it and feedback from the industry on how it's working, and we'll all come to terms with how those clauses can be used effectively. How's that?
Well, I'm just trying to get my head around the airlock actually, and then someone's got to be walking in and moving air with them, and walking out and moving the air out with them. But briefly, and they'll not be in there for 30 minutes unless it's a dodgy airlock.
Yeah, we just need to read the words in the clauses and apply them as they're in there, and just look for practical opportunities to adopt the clarifications and improvements.
I do have another question that's very specific. I will show that to you separately because it is very specific and
we can probably jump to the room.
Yeah, I think
questions for the room.
I've got a question regarding about the battery exhaust. Does the new ES code, does it give you the variant exhaust rates for different types of batteries?
No.
Because in NFPA 70E, it lists out at the table where the different types of batteries that you want to use in your building. It gives you different ventilation flow rates, and it differs from the traditional batteries that you have to the new batteries that we're using now.
Yeah, so battery ventilation is outside the scope of 1668 Part 2. So where we're dealing with those sort of things, we need to be referring to other codes and standards for those requirements under different regulations usually.
Sorry, just Ty, and then we'll come to you.
One of the most contentious exhausts I've come across in the recent years in regard to air discharge is the exhaust for diesel fuel, for diesel fuel
From a
from
pump?
fire pumps or from genset. It on paper, based on 2012 version, it is type A effluent.
No. The type A effluent needs to be an exhaust, which is air that's been removed from an enclosure. But that's what a lot of people have been dealing with. So that's why we're trying to address that with a clarification. The features you're talking about, that exhaust, that's part of a pump set under a different standard. That standard really needs to be prescribing how that's exhausted. What 1668 can do now is say, keep your outdoor air intakes away from it.
Yeah, but how about say genset exhaust? What's your take?
Oh, sorry, that's covered as well in that same reference. You've got to keep your outdoor air away from those internal combustion exhausts.
So that means that it doesn't need to go all the way up to the roof, the top of the building.
You need to move your outdoor air away from it. What you do with the genset product is not governed by the 1668 standard.
Which is particular peculiar because say it is pollutant, it is flammable.
It's not mechanical ventilation though. So I'm not dismissing the concern and the need to design suitable features for it, but the scope of this standard is limited to mechanical ventilation coming into and going out of enclosures in the building, predominantly occupied by people.
So for machinery exhaust, then it will be covered by something else.
When you say exhaust, you're talking about a mechanical exhaust. You're talking about
Say the flue gas, say for example.
yeah, so that's covered by other. Well, it needs to be covered by other standards, and I know there's ambiguity in those other standards. 1668 can't solve that.
Yeah,
We also didn't solve stage 3 tax cuts. I mean, sorry.
You suggest which standard I use?
No, I don't know off the top of my head.
Yes.
Now, we had a question over here. Then I've got an online question.
First of all, thank you both for the amazing presentation. Really appreciate it. My question is regarding to the occupied spaces. So it's whether it's occupied for 30 minutes or more per day, but
Per person.
per person. What if, does that include a person, let's say if it's a storage room that no one, let's say, actually occupies? How do you actually determine, or whether he comes in for 15 and leaves for another 15, like how do you actually put a time limit or put actual definition on what kind of space will be occupied for more than 30 minutes per person?
Let's look at it from the way of how complicated it is at the moment,
Yeah.
where there's no apparent exemption for how long someone goes in there or not. If they can be in the space to occupy it, which is usually the purpose of the door being there to allow them to go in, the building code just requires that it's ventilated. What we're trying to do is acknowledge that there's other ways of effectively exchanging air within that space for suitable reasons. It's not going to cover everything, it's not going to solve everything, but there'll be a number of opportunities that come from it. And I think as an industry, we'll start to develop an understanding of patterns and solutions that work for different types of spaces. And then over time, the standard will be able to be updated and accommodate more.
So at this stage, again, the definition falls to the engineer, and obviously different engineers have different interpretations or different logics, I would say. Where do you draw the line in that kind of clause?
If you're certifying it, you need to make those decisions that you're willing to put your name against,
Yep.
for example. If you're not certifying it, you need to be making sure, well, whoever's certifying it needs to be confident that they're making the right decision there and be able to stand by that.
The coroner might have a view.
Well, and that's genuinely something I talk about in other training sessions. We do need to stop and think, you know, are we making the right decisions for the community and people who are using these spaces? So it's not going to solve everything. I think it's clearer than it used to be, or the opportunities are clearer.
I completely agree on that point.
Like I said earlier, 2024 is not the end of 1668. It's a step in the direction of some clarity and some opportunities in ventilating appropriately. Feedback from the industry in response to how useful this is will be really good.
That's good. Thank you.
A couple of quick online questions. Operating theatres. Is it intended that all return and exhaust air must be drawn from a low level and that ceiling exhaust is not permitted?
Can't remember that detail, I'm sorry.
It's clause 5.3.7, Brett. Okay, question on notice.
Operating theatres have changed. I will confirm they have changed. I just can't remember the details.
Okay, we'll answer that one offline.
We can try.
Okay, all right. And also something here that the New Zealand G4 building code still references 1668 Part 2, 2002.
I've heard that. It's really interesting. It was never adopted in Australia for all sorts of other reasons.
No, that was 2012.
No, it's 2002.
Was it the 2002? That was the tobacco smoke.
Part of it. There's also that had natural ventilation requirements in it that the building code didn't want to have in there. So that was moved to 1668 Part 4, which you might have seen is now going to be referenced in the building code. So it's an interesting sort of...
Yeah, but they don't care about any of that. They care about have you heard whether the new standard is going to be adopted by the...
It was referenced in the public comment draft for the 2025 that went out recently. So it was a clear intention that it was intended to be referenced.
In New Zealand?
Oh, sorry, in New Zealand. No, I don't.
Most people utilise this version.
Most people utilise the latest version. We've got a genuine Kiwi in the room.
I once gave a presentation in New Zealand on 3666, and someone from the New Zealand government stood up and said, "Yep, we'll adopt that," and that was it. So I like governments that can make decisions like that. Okay, I'll come to the other one later. We've got a few. Leo? Oh no, sorry. Okay.
Thanks for I just unfortunately had a question on the unidirectional operating theatre, which they have taken offline as well.
Maybe. Yeah, but there's a lot of people involved in the preparation of the standard. We can't all be across every detail of it.
Yes, and it just because Melinda, I feel like I should ask the question, being that's all there for us.
I'm totally fine.
It's just something that I've always kind of had a burning question in terms of Green Star when it refers to 50% or 100%.
There's a bona fide GBCA person in the back of the room. Oh, sorry, I'm going to call him out if it's too hard.
In terms of what everyone considers 50% or 100% increase over the minimum rate of 1668.2's flow rate.
Can you repeat the
So, I suppose from a commonality across the industry, there's a credit given for indoor air quality when it comes to Green Star credits. There's 1 credit, there's 2 credits for the parts per million, 750 or 800 parts per million. And the compliance pathway is twofold. One being 50%, I think, increased over the minimum ventilation rate for 100%. And I was just curious what the common thoughts were. What is the minimum flow rate?
It depends.
Yeah, that's a terrible answer, but it does depend.
If you've got a high efficiency filter and it's an office, I think it's 7.5 litres per second per person. That's about a 50% increase to 11.25 litres, and it's 15 litres for 100% increase. That's only if you've got high efficiency filters. I don't really know what they are, but the assessors do, and that's the important thing.
Do I need to go to each? Can I just add to that once you go over your 10 litres a second, 1668 doesn't require the filters to be in there anymore to then get to the 7.5. It's a loop that we get
So you need to talk to this guy at the back. Pretty sure.
I think that's a discussion for later.
I'll take that one offline.
Yeah.
Updated.
All right, I think Leo.
I just have a question for, there's been a lot of concerns from landlords and tenants coming back from work, and normally they have safety concerns mostly because of COVID, and they're looking for the mechanical engineer to certify that the building is safe. And normally we can only certify to 60 and 68. I'm just wondering whether there's been any considerations on changes as a result of COVID.
There were considerations, and we waited and waited and waited, and the likes of the World Health Organization suggested we should have minimum ventilation rates in the order of 10 litres a second per person. We thought, well, we're already doing that. And it became very clear that the importance of maintaining the systems, the real significance of making sure the buildings are actually being maintained to achieve what was delivered was probably something that needed to be focused on a little bit more. So there was nothing that came back from the industry on particular details that needed to be changed in 1668 to be dealing with that. But we did make it very clear that the standard doesn't address infection control.
Right here, I also have an answer potentially around well health and safety.
Yes, that's what I'm saying. So yeah, I'm a well AP. So yeah, to answer your question, actually, the IWBI have the well HFR rating that addresses air for well in terms of COVID. The HFR actually is specifically well invented for this situation, and that includes air filter and also for cooling coils. Then they have one solution that involves ultraviolet radiation of the cooling coils, so to make sure the virus or bacteria or all sorts of bad things are killed in the airstrips.
Good summarize. Talk to Ray and he'll certify you.
Now, a couple of online quick ones before we go back to the audience. I'd like to say, by the way, that the New Zealand conversation is going wild now. There's a few people jumping in there, which is great. You might not have to answer anything at this rate. A question from Amir: using ERV, is there a new distance between the relief air outlet and air intakes? An energy recovery ventilator?
I think it's probably already covered in the old clause 2.9.
No, don't say your clause. You didn't know what 5.3.7 was.
There was the non-required discharge clause or something that was in there. That
okay.
Probably addresses that, depending where you're picking up your air from.
All right. And is the intent of the simple procedure to have the 25% reduction of outside air having a minimum filtration grade of F6?
Well, there's filter options now. I can't remember the filter grade, but there was a very simple calculation for it where you could reduce your outdoor air quantity as long as, I think you had to be recirculating at least 50% of the air through the filter. So it was a very simple application.
Okay.
Yeah.
So there's a simple answer.
And
we just got to go look.
There's a detailed option which may give you a better outcome. But there was a simple way of adopting Appendix D filtration.
Okay. All right. Sorry. Our New Zealand friend.
The filtration requirements in Appendix D. What's driven the increase in filtration to F6 as minimum when the old standard was F5?
I can't remember that part of the conversation. I don't remember it being incremented up to F6. Is that what it says now?
Yeah.
Okay, thank you.
There'll be a filter company involved, I'll be certain of that.
Not in the commercial sense. I can't recall the discussion. Possibly for as close an alignment as possible to the other standards. I can't remember the detail. But yeah, remember, like I said before, the options that are in there don't necessarily mean they're direct equivalents, but we would have had to sort of line them up as well as we could. I don't know, I'm sorry, but I can look into it.
Oh, that's,
Putting a direction.
we use, the borrowed ventilation for occupied areas.
Borrowed ventilation for occupied.
Suppose I've got an enclosure A, I'm supplying more pressure than what is required.
I think one of the limitations was it could not be an occupied enclosure,
Yeah,
that
that's
borrowed
what I'm saying,
ventilation.
but then I not get transfer that air and use it as a ventilation for the enclosure B.
So I think you'd be looking at the detailed calculation process where there are some provisions for transfer of residual outdoor air. You may still need a minimum proportion of introduced outdoor air to be doing that, but it's a bit more complex to be.
Has it been changed now in the revised one?
Not to just transfer air to an occupied space that doesn't have its own air. I beg your pardon?
Nothing has been changed on account of the occupied enclosure for borrowed ventilation. Because there was a.
Not for an occupied enclosure, no. We've got to work or progress these things incrementally and conservatively just to make sure the standard's going to be appropriate. So we've adopted the strategy that was already in there for borrowed ventilation for natural ventilation, but limited it to certain applications before it just runs wild in an unintended way. So it is quite limited to start with. We've just got to see how that goes and then it's
Standard does not encourage to use borrowed ventilation for occupied enclosure.
It doesn't allow it, is my understanding. It doesn't mean you can't use a performance solution for these things, but you've got to do all the verification to support it.
But as per standard, it's not encouraged or it is not.
I don't think the standard allows it. I think that was one of the items that you could not ventilate.
Somebody wants to do it, yes.
Performance solution. And you can do that for any, if you do a full-blown performance solution, you don't even need to read 1668 part 2. And that's okay. And 1668 actually has some guidance in the appendices on, well, if you're not going to read these standards, here's at least a list of some things you should think about. So
But you've got to buy the standard before you get to that.
Interestingly, I was asking ChatGPT today for a bit of an update on 1668 part 4 2024. It gave some interesting answers. I don't know where.
Hope they're better answers and hope they're better answers than your pictures. Don't know about the shoes, Brett.
I was expecting more shoes.
Sorry, we had a question in front of you.
Hi, what are the options of using the new 1668's reduced flow rates, for example, for car park, for a current project before the adaptation of the new MCC?
I've heard of a number of projects that are already pursuing performance solutions to adopt it now because it's a published standard. It's an easier process to develop a performance solution when there's a published Australian standard, but it needs to be done as a performance solution because it's not referenced in the building code yet.
Yep. And like you said, the process for that is referenced in that appendix.
A2G1, I think. So you've got to start off with a performance-based design brief. You've got to have a stakeholder meeting. You've got to do the analysis, the evaluation, the reporting. It's a very costly process. So there's a lot more involved in the design to get the gains in the construction later on.
Yeah, thank you.
Sorry, a quick online question. Does 2024 version provide any information on CO2 level concentration range required for various spaces for demand control ventilation?
The actual values, there was only ever commentary in 1668, and I don't think those numbers have, the upper end was bumped up to 850 parts per million just for alignment with what's in the NCC verification method.
But no definitive rates for specific enclosures?
No, I think there was always a requirement that you need to determine the rate that's appropriate. I think there's good guidance in the likes of ASHRAE and some other international documents on that.
Okay.
But it doesn't have to be CO2 for demand control. It needs to be in direct correlation I think these are the words, direct correlation to the actual occupancy.
And you did mention in your presentation.
Occupancy schedules. If you've got absolute confidence that people are only going to occupy the space in accordance with an occupancy schedule, you can use that.
Okay.
Hey, Brad. Thanks for the presentation. For the high performance dwellings and the lowered continuous flow rates and the air tightness testing of the filling envelope, is that saying the intention that you can only reduce them if the building envelope is
It's been tested after it's built.
it has to be tested.
Has to be tested.
If it's 5 meters cubed, if it's more leaky, you can't.
It's more leaky, you can't implement it.
Okay.
Which in New South Wales, if it's in the various regulated forms of building classes, you'd need a variation to undo that part of the design. So it's to stop people just saying, yeah, I'll do it, and then it just doesn't get built properly. It's you need control of the air leakage to be able to use it effectively.
Okay, that's good.
Is there any clarity in the update for car parks as to whether they whether the extract and supply points are required at high and or low level?
Low level was required after the 1991 edition. It's just it's silent on it now. It doesn't specify it.
Wasn't it included for diesel vehicles?
I think so.
I don't think the low level
Low level is not required.
hasn't been
That is super.
got dropped in the 2002 edition.
Okay. It's a good job you're giving the presentation and not me then, isn't it? That's
We're all using the same.
Okay, I think we've got time for one more question. Any last question anyone wants to?
I'll be here till I'm kicked out.
Just for the we've got one now. Are backdraft shutters on each spigot considered sufficient to minimise cross-contamination? Minimum separation distances between discharges and discharges where the respective exhaust system operate intermittently. For example, with some apartments and multi-unit developments, a single discharge plenum is used for wet room exhaust and kitchen range hood exhaust.
Yeah.
Are backdraft dampers or shutters on each spigot considered sufficient?
The standard doesn't say they're considered sufficient. You can think of all sorts of scenarios where you get toilet exhaust going back through the range in that arrangement. I've seen those sort of arrangements, but the standard doesn't permit that. They've got to be separate, and the exhaust has to be to atmosphere, so it'll have to be all the way out to the facade.
Okay. Well, look, for those of you online, if you have got any more questions, if you put them into the chat, I'm sure Sharon, who's hiding round the corner, is very eager to collate those questions and get them answered by the panel, and we'll find a way.
We paraphrase a number of similar questions and I don't know, do a newsletter response or something, or a newsletter, something like that, maybe.
We'll make it up.
I'm offering up someone else's time.
Absolutely. Yeah. Sharon's going to answer them because she listened to the whole presentation.
Just the ventilation.
I think it used to have.
Address the indoor air quality.
It used to have indoor air quality in the title. I can't remember when that was dropped. I don't think it's in the 2012 version, but it used to be ventilation of buildings for indoor air quality or something like that, which was what it was intended. But it doesn't address every contaminant in the building. It's just using dilution and filtration.
It does not do that.
It's dilution and filtration for the benefit of amenity for most people most of the time. That's
Just bypasses the indoor air quality issues.
it provides an acceptable level of amenity for most of the time.
Somebody can follow the standard and say everything is okay.
Well, that's someone else taking out the leap to say everything's okay. That's a different thing.
If you follow the standard and it's referenced in NCC, an engineer can claim, yes, everything's okay.
Yeah. We'll also need to remember the building code only prescribes the worst construction and provisions that we're legally allowed to get away with. So you're allowed to do more.
Now you can continue this conversation, but you two are standing now between us and drinks. I'm not sure about the people online. I'm sorry, you're going to have your own drinks. But look, that was fantastic. That was fantastic from both of you. You got off very lightly on the questions. I did want to say, can I get you all to thank our speakers in the usual way? And for those of you that are here, there's a few drinks available. And for those of you online, bye.
Come and visit.
Thank you.
Thank you.